In this lecture, we're going to see how we can overload with const references. And this is going to be super easy. Here we have two functions and they are overloads on the max name here. So they are going to be having different parameters here. And you see that the first overload takes int references and the second one is going to take const int references. Int reference and const int reference are two different types. So these are going to be valid overloads in C++, and we can compile our program with these two guys and it is going to work. The only thing you really need to be careful about is that the first guy here is going to take parameters by non-const references. So we can go through these references and really modify the data that was passed to this function, and changes are going to be visible on the outside of this function here. With the second one, we can't do that. If we try to do that, we're going to get a compiler error as we see here, because the reference here is a const reference and we have no business going through that to modify the data. This is really all this lecture is about. You can set up code like this and it is going to work really fine. Here is a simple example of how you can get the two functions called. We have two variables a and b, and we are calling the max function with direct variables here. So this is going to call the non-const reference version. And if we go down and explicitly set up const references like this and call our function with these const references, we're going to get the const reference version called. This is how you can call it. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is overloading with const references. We're going to grab our template files and put them in place. Let's do that. And we're going to open this little guy in Visual Studio Code by dragging and dropping like we have been doing all along here. We are going to open the main CPP file, close the left pane here. We don't need it anyway. So we're going to clean this up and we are going to set up our two functions that we saw in the slides. There are two overloads on the name max here, so they have the same function name, but they will have different parameters because that's how function overloads work in C++. The first one is going to take int reference as a parameter. The second one is going to take const int reference. Int reference and const int reference are two different types in the eyes of the compiler, so we can use this to our advantage to set up overloads on the max function here. If we compile our code, it is going to work. Let's try and compile this with GCC. You see the build is good. Now if we set up variables, the compiler is going to select the most fitting overload here and call it to compute our maximum here. One thing you need to be careful about is that with the first overload here, we are passing a non-const reference, so we can go through that to modify the data that was passed to this function here. So we can change a here, and the changes are going to be visible on the outside of the function here. Let's say that. Okay, that's the effect of using a reference like we are doing here. But on the second overload here, we're not going to be able to apply this change, because the parameter was passed by const reference, so we are not allowed to go this a name and modify the data this reference is referencing. If we do that, we're going to get a compiler error. So if we go down and set up a few simple variables and call our max function with them, we have a and b, which are int. They are initialized with 45 and 85 respectively. And we're going to call our function with a and b. Because we are passing in integers like this, the compiler is going to think that the first overload here is the most fitting and it is going to call it. If we build and run the program, we're going to see this guy called and we're going to print our maximum here. I don't think we really need these guys in here, so we're going to take them out. And we're going to see our maximum printed out, and we are also going to see which function was called. We're going to see this output on the console. Let's build our program. We're going to use GCC like we always do. The build is good, so we can clear and bring up a terminal so that we can clear properly. And we're going to clear and run rooster. Now we're going to see max with int reference was called, and the maximum is 200. Why is that? 200. Where is this coming from? Let's look at what we are doing in our max function here. We are changing A to 200, and that's what is going to be returned here. See what you can do with these changes here. Let's take this out because this is going to confuse us, and we're going to build again. Okay, the build is good. We can clear now and run rooster, and now we should see 85 as our maximum. Okay, I hope you saw that because we are passing an unconst reference here, we can really do some damage and change the data from the inside of the function, and the data is going to be visible on the outside of the function. We have changed A here inside the function, but we were really affecting the outside value here, which was A, through our reference here. So if you do this, be sure it is going to do whatever you want in your application. I am going to take this out because this is going to make the code confusing here. And we are going to go down here and set up other variables that are going to target this second overload here. And these variables are just going to be const references. So let's put them in here. And we're going to take out this little guys because we are just cluttering our terminal with useless output. We're going to have these two references and we're going to call our functions using them as parameters. Because they are const references, the compiler is going to see that this guy here is the most fitting function definition, and it is going to call this function here. So we're going to see this output, and we're going to see our maximum printed as max2 here. So let's do that. We're going to build again with GCC. The build is going to be good. We can clear and run rooster max with const int pointer called, and the maximum is 85. This is what we expect. And for the second call here, the second overload with const int reference was called. This is really all this lecture was about, to show you that you can set up overloads based on whether your reference is const or not. If this makes sense for your application, please go ahead and take advantage of this. But for the second overload here, you should know that you can't go through this reference to modify anything about this reference here. If you try to do that, you're going to get a compiler error. Visual Studio Code is going to give us a squiggly line, and the problem is going to be that we are trying to modify something that is const, and if we try to build with GCC, we're going to get a compiler error, and it is going to be saying assignment of a read-only value. We have no business modifying data through this reference here, so we're going to comment this out and build again because I don't want these errors left in here. The build is good, and this is really all we set out to do in this lecture. We are going to stop here in this lecture. In the next one, we're going to show you that you really need to be careful if you are using function overloading with default arguments. Go ahead and finish up here and meet me there.